Hey everyone, my name is Venelin, and in this video we're going to finish the document classification series. Today we're going to build a Streamlit application which uses our pre-trained model, and you can essentially add or upload an image to it, and then you're going to get the prediction. Also, I'm going to show you some cool ways to visualize the outcome or the probability of the model. And we are going to upload this to HuggingFace Spaces so other people can play around with the demo as well. This is a demo app of what we are going to build today. It is hosted on HuggingFace Spaces, and as you can see, expects an image of a document, and I'm going to pass in one image from the test set that I've already downloaded on my machine. And you can essentially use the URL right here in order to test the demo for yourself. But after you upload this image, you're going to see that the demo app is showing you the document image itself. It is telling you what our model is predicting as a type of this image. And also it is giving you this, which is essentially the probability distribution of the model. So I've called this file nodes JPEG, so I know that this is a nodes image. And as you can see, our model is correctly predicting this. So in order to build this demo, I've used Streamlit, which is an app building library that allows you to turn some simple scripts into applications, and it is using no front-end requirements, like you don't have to use React or any other JavaScript library, and it's really simple to work. There is a web page of it, streamlit.io, and it works exceptionally well. I've been told about this application originally by a colleague of mine, and it seems that the Streamlit developers have bring out this to a whole new level, and now it is very full ecosystem. And I'm going to show you how you can host our Streamlit application on HuggingFace Spaces later on. There is also a GitHub repo of Streamlit. It is an open source library. It's very popular, as you can see, and it allows you to use some very simple Python in order to create those amazing applications. So to start our project, I'm going to create a directory called document classification, and I'm going to enter that directory. All right, so this should be an empty folder right now. After this is done, I'm going to use pyenv to create a virtual environment using Python 3.10.9, and this is the command that I'm going to use. This should go ahead and create this virtual environment. If you don't have this version of Python on your machine, you can install it using pyenv, but other than that, you should be good. So next, I'm going to use the new virtual environment in the current directory, and as you can see, my interpreter is already defaulting to this. All right, so let me just check the Python version here, and yes, it appears that we are running this. All right, so next I'm going to have to install some libraries. I'm going to start with PyTorch. This should go and collect the latest version of PyTorch. After this is done, I'm going to install some helper libraries as well, which are going to help us to format the code that we want to have in our project. These will be nicely integrated with Visual Studio Code, so you should be good to go with those. So this would be Flake 9, 8, black, and isort. All right, I have those already cached, so those should work just fine. And then I'm going to go install the transformers library, easy OCR for our OCR engine, Plotly Express, so we can create the plots. And finally, I'm going to install the Streamlit library. And for the Streamlit library, I'm going to follow the HuggingFace Spaces configuration recommendation because those guys don't support versions larger than 1.15.2. So yeah, you have to, at least of this time, you have to use at most this version, while the version on GitHub is 1.17, but maybe there will be support for this version later on. And I'm going to use pip to install this version. Okay, so this should pretty much get you started with the all necessary libraries. And I'm going to start Visual Studio Code in here. And as you can see, this is an empty project. So I'm going to create a new folder called VSCode. And in here, I'm going to input settings.json. So this will be pretty much the default settings for the app that I'm going to use. And the settings are going to be something very simple, I would say. I'm going to use black as a formatter. Then I'll have Flake 8 enabled. And I'm going to use isort and organize the imports on safe. And I'm going to use the py1s extension. So these are pretty much all of extensions that I'm using that are recommended by Visual Studio Code for from Microsoft essentially. So I'm going to also create a file called flake8 or .flake8, and in this file I'm going to specify the settings for flake8, which are going to be that I want the maximum line length to be 120. So this is the default length that black is using, so I'm going to use the same thing here. All right, and I'm going to build or add the file app.py, which is going to be the file that we are going to work on. Now that the project is set up, I'm going to start by adding some code, and most of it is going to be based on the notebook that we've already created. I'm going to add some imports. And pretty much everything should be running some warnings, since we are not going to use any of this, at least for now. So first I'm going to do some constants for which I'm going to first start by checking whether or not we are running on a CPU. So now we are using Torch, and then I'm going to paste in the names of the models that I'm going to use. So this is going to be essentially the tokenizer that we are going to download, which is the original tokenizer, and this is the model that we uploaded to the Hugging Face hub. So this application is going to work with our custom model or your own custom model once you have everything in place and you've trained a model for yourself. So next I'm going to show you how you can essentially write out the OCR reader and the tokenizer and or the processor and the model. So here I'm going to write three functions. which are going to be using caching, the caching mechanism that is still experimented from Streamlit. So I'm going to create OCR reader. I'm going to pass this for now. I'm going to create a processor. Pass this for now as well, and create our model. Okay, so these are the pretty much everything that we want from our model. I'm just going to pass on the skeleton of this app. So I'm going to use the singleton annotation here, here, and here. So this would allow us to run this part of the code essentially only once, since every time that Streamlit is rerun, is going to be re-render everything, but that's not what we want. We want just to load once the processor, the model, and the OCR reader in the memory, but never have to look through all of this again. So this should be just once done, and that should be it per app start. So the next thing that I'm going to show you is how you can use Streamlit to upload a file. I'm going to use the file uploader, and I'm going to pass a label here, upload document image, and then I'm going to pass in JPEG and PNG, which are going to be the formats that I'm going to use. And this will be the uploaded file. So if we have uploaded file here, I'm going to get the bytes of the file, and I'm going to use IO bytes IO for that. Get the value of the bytes. Okay. And next I'm going to use PO to open the image using the bytes. And at least for now, I'm going to show this image. And this will be the document that we've uploaded. So this should create a very simple Streamlit application. Let's run it. So Streamlit run app.py, and this should open up the application. And as you can see, we have this input box, which allows us to upload some files or images. And this is the image that I've just uploaded. As you can see, it's very fast. And it works as expected. Here is the label that we've already discussed about. I'm going to leave this running since this should be rewarding every time that we do some new code in here. Next, I'm going to continue with the OCR data. And to do that, I'm going to create a reader. And this reader is going to be created from here. I'm going to pass the language, only English. And I'm going to call this function from here. So now when I reload this, you can see that we are running for a bit the OCR reader, but once everything is done with the reader, then the uploads should be very fast. Yeah, everything works as expected, and there are no delays, even though that the reader has been initialized. So it will be get initialized only once. That's why we're using this experimental singleton. Next, I'm going to use the processor. First, I'm going to use the feature extractor or create one feature extractor from. So this, we don't want this to apply OCR for us. We want a tokenizer fast, and this will be the pre-trained from Microsoft. And then I'm going to return the feature extractor and tokenizer as part of the constructor of the processor. So here is the processor. And this should give us pretty much the same thing. If I restart this, creating processor, and it was pretty fast. It might take some time with your setup, since you have to go ahead and download the data. But here everything is already downloaded from HuggingFace, so on my machine it's a bit faster. Next, I'm going to create the model itself. And I'm going to return eval version of it, and I'm going to put this on a device, on the current device. So this should create a model here. Let's see what happens. Create model. It takes some time, but still it works just great. Let's try again an image. Okay, everything seems to be working as expected. So now we have everything that we need. We have the image, the reader, the processor, and the model. I'm going to continue with pretty much copying and pasting the create bounding box function, which we've already wrote in the notebook. So here it is. In here, I'm also doing the scaling. So this will get the OCR, put in the bounding box data, and apply some scaling, since LayoutLM requires this from us. So this will be a helper function for us. And I'm going to continue with the, let's say, the main part of this app, which is going to be the predict function. And this is going to take an image, a reader object, which is the OCR reader, a processor, and the model. So here I'm going to start by taking the width and the height of the image. And pretty much the idea behind this is going to be to return the predicted class and the probabilities from the model. So to do that, I'm going to essentially do the pre-processing steps, which are going to be pre-process the image by creating some OCR for it, then passing the OCR through the processor, doing inference with the model, and then taking the widgets, applying a softmax function in order to get the probabilities and return also the predicted class of it. So next I'm going to get the OCR result from the reader by passing the image. And I'm going to take the width scale, which is again 1000 because this is the default of LayoutLM, and then the height scale. And then I'm going to get the words and the bounding boxes from the OCR. I'm going to pretty much ignore the confidence and get the words and then the boxes. And I'm going to use the create bounding box function with the width scale and the height scale here. So we have the words, the boxes here, and then I'm going to get do I have a mistake here? I don't think so. Yeah, I'm going to continue either way. Huh, that's strange. Okay, so I'm going to take the encoding using the processor. I'm going to pass in the image, the words, the boxes, max length of the maximum possible length, 512, padding, max length. So I've added some spaces and this seems to be working now. Interesting that the formatter didn't end up catching everything for me. But I'm going to also apply truncation, and I want to return tensors in the format of PyTorch. So this is the encoding, and I'm going to use inference mode to get the output of the model. Again, I'm going to put everything on the device that I'm currently working with. And again, this is pretty much because of the spaces, I guess. And the pixel values. So this should be the output. And these are the widgets from the model. The predicted quas is going to be the argmax from it. So the index with the maximum probability or confidence. And then for the probabilities, I'm going to apply softmax over the widgets at the last dimension. And I'm going to flatten this and convert it into a list and return it. All right, so this is pretty much the whole predict function. It's not really that simple, yet we've already seen everything in the notebook. The only pretty much new thing is that I'm applying a softmax function in here, since, as you recall, I'm going to use this in order to display these probabilities here. So we will need that. And then the predicted quas. So let's call this function right now and see if we are getting everything as expected. Predicted quas and probabilities. Predict with the image, the reader, the processor, and the model. Let's restart this and upload an image. And since the image is here, I would guess that the prediction has worked. Let's print the results. And the probabilities. Let's upload this. So this is, this is the predicted label. And as you can see, this is running on the CUDA device. So I don't want this. I want this to be on the CPU and then item. So yeah, this should now return just the index of the predicted class. Yeah, here it is. So if I use detach, this should hopefully also work here. Let's try it out. Okay, so it appears to be working. And I'm going to now continue with essentially using this information. So the first thing that I'm going to do here is to move this there, and then I'm going to use Markdown to say that the predicted document type is the one of the predicted label, which is going to be the one that is from the ID to label. So let's try it out. And as you can see, this is running with others. And the predictions are very, very quick because on my setup, I'm using actually CUDA. So it runs much faster compared to what you're going to get if you're using just the CPU or hosting on HuggingFace Spaces. Just keep that in mind. So the final thing is, as compared to this, is going to be this plot or chart. And to do the chart itself, I'm going to convert the predictions into a pandas data frame. So here I'm going to do a document, which is going to be the model values from the ID to label. So this will be the balance sheets, orders, etc. And so this is a dictionary that I'm passing into the data frame as a construction to the data frame, if you will. And then the confidence, which are going to be the probabilities. Okay. Let's do this since we don't need it. Next, I'm going to use Plotly Express, which is already imported right here, this PX. And with it, I'm going to create a figure using the bar function. I'm going to specify the X to be the document type or the class, and Y is going to be the confidence of the model. And finally, I'm going to use Streamlit to say that I want to have a Plotly chart, and I want to use the whole container with that. I'm going to save it. I refreshed here, just in case, maybe not needed. Upload an image. And yeah, as you can see, we are running the whole complete application. So let's try it out with another document. For example, orders. Correctly predicted. And we have some small confidence in notes. If you recall, notes and others are relatively common looking, if you will, document types. So this is expected, but still the confidence is very high for the others, and this seems to be correct. Let's try it an income statement, something larger. And yeah, the model is very, very certain that this is indeed an income statement. So how can we upload this to HuggingFace Spaces so that we can have it for other users as well? I'm going to go to the My Hugging Face account, go to Spaces, create new space, and here I'm going to specify LayoutLMv3 YouTube, for example. As you can see, I have to choose Streamlit since we're using Streamlit app, and this will create a public space for us. Next, I'm going to stop the Streamlit app and open the document here or the folder of the application. So when we started this, there is a tutorial on how you can run through all of the files, and there is this documentation, everything is here, and you can go to files and versions and you can upload file. But before the uploading of the files, we have to specify another thing in our project, and this is going to be the requirements txt file. So in this file, you're going to specify the libraries that your project is going to use. And to do that, I will have to import the requirements that I've already built and we've already used. So these are the requirements. This is the requirements txt. Easy OCR, pandas, Pivo, Plotly Express, Torch, and transformers. So this should give you everything that you need for the app that we're doing. And here I'm going to specify or click add files or upload files. And I'm going to upload the app and the requirements file. And I'm going to use this commit message and then commit the changes. So this should start the commit of the space. And yeah, as you can see, we are already running a build using this app file and requirements txt. After everything is done and the build is complete, you can see the application is running and the build has finished up. So I'm going to again test with an image for balance sheets. And as you can see, it takes a bit longer on the Hugging Face Spaces to do the predictions. Yeah, you have a good loading indicator here. And this is the correct class again, the balance sheets. And so this concludes the document classification series. We've started with a simple dataset, a very simple idea, and then we continued through fine-tuning our own model using LayoutLM version 3. Then we used a notebook to do some predictions and have a look at the results, some very simple evaluation of the model. And finally, we've used Streamlit and HuggingFace Spaces to upload our documents or our model more likely to have a look at what the final application is and how we can make predictions using outside images. And as you can see, the final application is performing very well. I would say that you can have a lot of fun with experimenting with Streamlit and HuggingFace Spaces, as they provide this very good opportunity to have free resources and play around with your ML experiments. Thanks for watching, guys. I will upload the whole notebook that is essentially running through all of the steps that we've discussed throughout these videos, and I'm going to link the notebook into the description of the videos. I'm also going to create a playlist so you can go through the videos as well. As once again, thanks for watching, and please like, share, and subscribe. I'll see you in the next video. Bye.